In this lecture, we're going to learn about structured bindings. And structured bindings are a technique we have to access member variables of a class using some simple syntax. And suppose we have a struct, which is really a class with public member variables inside. And this is going to be modeling a point in C++. So we're going to have the coordinates of our point, which are double x and double y here. We could want to access the member variables of this struct very easily using the syntax we see here. So what we do is we use the auto keyword, and then we put square brackets, and inside we put the placeholders for the member variables of our struct. And if we do something like this, we're basically going to have a copy of the x member variable stored in A, and then we're going to have a copy of the y member variable stored in B here. So the order you declare things in is important. So we're going to go from the first to the last, and then we're going to go from the first to the last in this order here. So what this is going to do, it's going to assign the member variables of our point object to A and B here. This is what this syntax here is going to do. And one thing you should know is that this is only going to work if your member variables are public. If they are not public, you're going to get compiler errors, because this is really like accessing using the syntax here, point 1 x and point 1 y, and the compiler is going to put together the machinery to make this work behind the curtains of how it works. But this is going to work, and one thing you should really keep in mind is that what you have in A and B are going to be copies. So if after we happen to change our object, and for example in x we put 10.1 and in y we put 66.2 like we do here, and then we print A and B are not going to pick up these changes because they are just copies. So this is the syntax for structured bindings. There is a lot more to this, especially with other data structures in C++, but for now we're going to use this in the context of a struct. Another thing you should know is that it is possible to capture a structured bindings inside a lambda function. And this is something that was added in C++ 20. So for example, we can capture the A variable here in a lambda function, and we can use it inside the lambda function like this. Another thing you should know is that at the moment, it is not possible to do structured bindings that use references. If you want to do that, you're doomed. You shouldn't use structured bindings. But I just want you to know about this syntax. And in this lecture, we are learning about it in the context of struct. Because structured bindings can do really much more, especially in more advanced data structures, as we will see later in the course. But for now, I just want you to be aware of the syntax here, and it shouldn't be foreign to you if you see it starting from today. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is structured bindings. We're going to grab our template files and we're going to put them in place. And let's open this in Visual Studio Code by dragging and dropping here. This is going to bring us our folder here, and we can close the left sidebar. We don't need it here. And we're going to put together a struct. It is going to be struct because we want to have public access to our member variables. We're going to name this point, and we're going to put data inside. We're not going to put anything complicated in here. We're just going to put in double x and double y. And this is going to model our point in C++. What we can do, for example, is set up a point. Let's do that in main. We're going to call this point 1. And then we can say point 1 x and assign a value to this. Let's say 5. And say point 1 y. And we're going to assign a 6 to this. And the moment we do this, we can print this point. For example, let's put in a function which is going to print a point. We're going to say void print point, because we don't want to do stdc out every time. So we're going to say print point here, and we're going to take a point by reference. And inside the body, we're going to say stdc out point. We can say that. And we're going to say x and y for this point here. So we're going to say px, and we're going to say y, it's going to be py. This is how we access member variables of a struct directly. And we're going to put the closing square bracket, and we're going to end this with stdendl. I think this could work. So now we could come here in the main function and say print point and pass point 1 here. This should work. So let's build and run this. We're going to use GCC. You are going to see that the build is good. So we can bring up a terminal and really play with this. Let's clear and run Rooster. You're going to see that we have our point. But we can really access this point using structured binding notation. And the way we do that, we say auto and we put square bracket, and then we say the variables that are going to capture the member variables of our struct. So we're going to assign point 1 to this thing, and what this is going to do is assign the X member variable to A and assign the Y member variable to B. And now if we print A and B, we're going to have the member variables printed out. Okay, so let's do that. We're going to say std out A, and we're going to see the value printed out here. And we're going to print B, and we're going to see the value printed out here. Okay, let's do that. We're going to build. The build is good. We can clear and run Rooster. This is going to give us A and B. Another thing you should know is that A and B are copies. They're not references or anything that has anything to do with the member variables we have in the structure here. So we're going to prove this. We're going to change X and Y in our object. We're going to print the point, and then we're going to print A and B and really see that nothing was affected in A and B here. So let's do that. We're going to say point 1 X, and we're going to change this to anything really. Let's put in 44.1, and then we're going to say point 1 Y, and we're going to put in 55.2. Why not? And then we're going to print point. So we're going to say print point, and we're going to print point 1 again. And after this, we're also going to say what we have in A and B. Okay, so let's clean this up a little bit because I think we have a lot of spaces in here. But we can space these things out because I want you to see them. What we are doing here, we are setting up a point. We are putting in values and then printing the point. We are using structured binding syntax here to assign the member variables of this point object to A and B. So A is going to have the value we have in X, and B is going to have the value we have in Y. If we print this, we're going to see that. Then we're going to modify our point, and then we're going to print the modified point. But we're going to see that because A and B are just copies, the change we do here are not going to be reflected in the second print we do for A and B here. This is the goal we have. So let's build again. The build is good. We can clear and run Rooster. So you see that A and B are 5 and 6 first here, and then we modify our point and make it to have an X value of 44.1 and a Y value of 55.2. But you see that A and B don't grab these changes because A and B are just copies. Please note that at the moment it is not possible to do structured bindings that capture references. So for example, if you're trying to do something like this, that's something somebody might do. If you do something like this, you're going to get compiler errors. This is not supported. Let's try and build and show you the problem. The compiler error is going to be really weird, and we're going to say expected identifier ampersand token. This is really not supported. This is what the compiler error is trying to say here. So let's take this out. And the last thing I want to show you is that it is possible to capture structured bindings in a Lambda function. And if this is something that is important or useful for whatever project you are working on, please use this. So for example, we can set up a Lambda function. We're going to say autofunc, and we're going to say the capture list is going to have A. We're going to capture the structured bindings variable here, and then we're going to put in our parameter list, and then we're going to put in our body, and then we're going to print A here. We're going to do stdc out A and say that it was captured, and we're going to print this out. And then we're going to call this Lambda function here. So we can say func, and this is going to call our Lambda function. Let's build and see that this is actually going to work. So this is working properly, but notice that if you don't capture A, you're going to get a weird compiler error. You see we have a squiggly line already here, and if you build, you're going to see that you're going to have a compiler error along the lines of the A variable here was not captured. Okay, so we're going to have the Lambda has no captured default autofunc, and it's going to say that A was not declared in the Lambda function here. So this is the error you get. You need to capture A to be able to use it in the Lambda function here. And I have to say that this is something that is possible in C++20. In earlier versions of C++, this is going to give you a compiler error, so you should know this. Let's build and show you that this is going to work. We should see A captured printed here on the console. Let's clear and run Rooster. And we have A captured 5 here. If you want, you can capture everything by value. You can use the equal sign to do that. You already know this. And this is also going to work. And this is also going to capture B. Let's do stdc out. We're going to say B captured, and we're going to print B here. And this is going to work because we have captured everything in the context here in our Lambda function. If the capturing stuff is confusing, please go back and watch the chapter on Lambda functions. We talked about these things extensively. For now, we're going to build and run this. We're going to use GCC for that. You see the build is good. We can clear and run Rooster, and we're going to see that B is also captured, and the value is in here. This is really all we set out to do in this lecture, teaching you about structured bindings. The syntax is what you see here, and if you do this, you're going to have a slightly nicer way to use the member variables of your struct. One thing I don't think I talked about is that structured bindings, like we do here, are only going to work if you have public member variables. If, for example, we change the struct here to be a class, this is going to make the member variables private by default, and we will have all kinds of crazy problems. But you see that even on our structured binding, we have a squiggly line. This means that we can't really use structured bindings on a class which has its member variables private. So if we change this to be public, let's do that. We're going to see that the squiggly lines are going to go away because structured bindings only work if your member variables are public here. Please remember this, and if you remember this, you're going to use structured bindings however you want. Another thing I should mention about structured bindings is that it is critical to use the auto keyword here. So if, for example, you change this to double, let's do that because some of you are going to ask this question. We're going to see that we have a squiggly line, and it is saying a valid specifier for structured binding declaration. So structured bindings are only going to work if you specify the auto keyword here. This is what the C++ compiler is going to expect. If you violate this, you're going to get weird compiler errors. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.